Hello. We're still in Chapter 3, and we're going to discuss something a little different. You'll notice that we've already talked about the 68, 95, 99.7 rules. So basically, here's an example we did, and this talks about female heights. And notice if you're 64, 61.5, or 59 inches, or even 66.5, we can find out what percent fall in each area. But what if you were between, like 65 or 68 inches or 60 inches? This wouldn't work. Same thing with our second example, talking about length of human pregnancies. If you had one of these dates, then we could figure out what percent fall below or above. But if you were in between, how would we do that? So that's what the next section is all about. So the next section talks about z-scores. So basically we need a standard unit which measures a value relative to the sample rather than with respect to some absolute measure. And that standard unit is called the z-score. Now to find the z-score, we use z equals x observation minus the mean divided by your standard deviation. So let's kind of figure out a z-score and then talk about what it means. So let's say the question is, find the z-score when the average height of females is 64 inches and the standard deviation is 2.5 inches. What is the z-score that you're looking for a height of 67 inches? So to label everything, 67 is what we're looking for, the x. The average is 64, standard deviation is 2.5. So if you fill in the formula, it'd be 67 minus 64 divided by 2.5 to get us a z-score of 1.20. Now I'm going to point out a few things. Number one, when we go to our calculator, be careful when you type this in. If you do 67 minus 64 divided by 2.5, you'll notice you get the wrong answer. So be very careful. So for example, parenthesis 67 minus 64, close parenthesis, divided by 2.5, that will get us the right answer. Okay, so be careful of that. Then also notice I went 2 decimal places. Even though we got 1.2, I put 1.20. Well, what we have here is the z-score. That is not our percent. Our answer is always a percent. The z-score is going to lead us to the percent. So the reason why I have 2 decimal places is when we go to a z-table, let's say, let's scroll down, here's a z-table. Notice we have a negative z-table with the z here, and we have a positive z-table. So the example we just did was 1.20. So if I was going to use the table to find the percent, then I would go to the z, positives, 1.2, and then notice I have a whole row of values. So the second decimal place is here. So if I was looking for 1.20, it would be 1.2 the row, and 0 would be the column, so I would get 0.8849. Now, what does the table tell us? The table always tells us the percent below, percent below, percent below. And to help us remember that, if you look at the picture here, it's shading below. It's shading below, even on the negative side. Another thing you'll notice is the negatives are a small little area and the positives are a high area. Well, we're going to talk about what those z-scores mean a bit. So if I go back to this picture with the female heights, notice that this is the center, 1 standard deviation, 2 standard deviations, 3 standard deviations, -1 to the left, -2 to the right, to the left, -3 to the left. So if I had 1.2, that would be here. We're finding the in-betweens. So if I was doing less than 1.2, it'd be a larger percent. If I was at -1.2, less than, it'd be a smaller percent. So you'll notice that all of the negative ones are less than 50, because they're to the left of 0, and all the positives are greater than 50, because to the right of 0. But the table always tells you less than. So let's just be comfortable with the table. So I've given you some values to basically start off with, and we have 0.23, again 2 decimal places for the table. If I had 1, we'd have to get 2 decimal places, 1.00, 0.20, -2.10, -1.25, and 0.04. So I'm just going to do a few of these. So I'll do 0.23. So we'll go to the positive, 0.23. That gives me 0.5910. Now remember, that's the table value, and that always tells us less than. So if I convert that two places to the right, we get 59.10% less than. If I did negative 2.10, go to the negative table, negative 2.10, we get 0.0179. So 0.0179 would be 1.79% less than. If it was too many decimal places and we'd round to the second decimal place, remember we're trying to get two decimal places, we're looking at them to the right. If it's 5 or larger, round up, 4 or lower, leave it alone. So that would be negative 1.25, negative 1.2, and then match it up with the 5. We get 0.0156, which would be 10.56% less than. Now remember, the table always tells us less than, but we can work the table backwards to find more than or other things, which we'll encounter soon. Okay, so be comfortable with the table first. So, why are we doing all this? We just learned 6895 90.7. This is another way, and I think you'll like it when we're done. So, let's do an example. So the first example says, the distribution of young women 18 to 24 is approximately normal, with a mean of 64 and a standard deviation of 2.5 inches. We're looking for what proportion of young women are less than 68 inches tall. So again, step one, what are we looking for? We're looking for less than 68 inches. Less than 68 inches. So that's step one. Step two, let's draw a picture. So if we'll find the z-score first, I'm sorry. So we find the z-score, what we're looking for, minus the mean, divided by the standard deviation. Be careful typing that incorrectly. You would get 1.6, 1.6, and then we're going to do another one if we use the table, 1.60, two decimal places. Now, I have these little lines here, but they're not really there. They're just kind of to guide you. If it's negative, it's on the left, positive is on the right, but we'll talk more about that. But positive 1.6, if we kind of remember, 0's here, 1's about here, 2's about here, 3's about here, negative 1's here, negative 2's here, negative 3's here. So 1.60 would be about here, and we're looking for less than. We're looking for less than. So to review, step one, find out what we're looking for. Step two, find the z-score, draw the picture. We're shading less than because we're looking for less than. Then we'll go to the table. So we go back to the table. 1.60 gives us 0.9452. Now, the table always tells us less than. The table always tells us less than. So we write down the number from the table. The table always tells us less than. We're looking for less than. It's a large percent shaded of the 100. So our answer is, convert to a percent, 94.52% of females are less than 68 inches. Now there's a less than example. Let's try a more than example. What proportion of all young women are more than 62 inches tall? So we're looking for more than 62 inches. Find the z-score, 62 minus 64, divided by 2.5. We find our z-score, negative 0.8, two decimal places, negative 0.80. There's your z-score. Excuse me. Now remember, it's on the left side, so it'd probably be about here for a little more accurate, but it's on the left side, negative 0.80. We're looking for more than. Now be careful. When we go to the table and look up negative 0.80, negative 0.80, we get 0.2119. Now, we drew the picture for a reason. This doesn't look like 21%. The table always tells us less than. The table always tells us less than. So this part's 21.19%, but I was looking for more than. So, since the table always tells us less than and we want more than, we subtract from 100. We want the other side. So 100% minus 21.19% would be 78.81%. So 78.81% of females are more than 62 inches. Okay, so we did less than, we did more than. Now let's talk about in between. So let's say I had two values. I want to find out what percent of young women are between 62.5 inches and 65.8 inches. So step one, find our z-scores. 62.5 minus 64 divided by 2.5 is negative 0.60. 65.8 minus 64 divided by 2.5 is 0.72. Now again, these aren't exactly accurate, but to give us an idea, negative 0.6 would be on the left, 0.72 would be on the right, negative positive. We're looking for in between. Now, the table doesn't tell us in between. It tells us less than. So when we look up negative 0.60, negative 0.60, negative 0.60 gives us 2743. Remember, 2743 is below, not shaded, not shaded. 0.72 gives us 7642. That is from this point all the way to the left. So the 7642 includes shaded and not shaded. The 2743 is not shaded. So if I want to find just the in-between, I would subtract them. So 76.42% minus 27.43% gives us 48.99% of women are between 62.5 inches and 65.8 inches. Now there's still a couple more problems I'm going to do, but I'm going to stop this video here. Practice these three.